Ladies and gentlemen, welcome to my presentation about superconductor busbars for aluminum plants. First, a few words about my person. I am an electrical engineer. I worked more than 30 years in high power applications. In 2000, I founded the company Vision Electric, and we engineered, produced, and installed high current systems for aluminum smelters and other industry plants on a worldwide base. In 2014, we established Vision Electric Superconductors. Based on the experience we made in the industry, we decided to promote superconductors for high current applications. Today, we are system integrators. We are providing turnkey solutions by combining conventional and innovative superconducting technology together. And today, I want to show you what we can do, what superconductors can do for aluminum plants. We strongly believe that superconductivity will change the world. Superconductivity is enabling zero loss power transmission, and through the innovative use of superconducting systems, we will create and contribute to a sustainable environment. We will create a better future for our children, not wasting energy just by the transport. If you compare standard aluminum busbars with our superconducting busbars, there are big differences. Normal aluminum busbars, they are losing energy on every meter they conduct current. And every megawatt hour which is lost on the way to the pot line is a waste. Therefore, we are convinced that superconductivity will give some benefits to aluminum plants. And the best is zero electrical losses during the transport of electricity. And that is possible because superconductors are a unique material and they can operate without any losses. In addition, they have an unmatched capacity. The current carrying capacity is very high, and the density is very high and unmatched up to now. This enables very compact, high power busbar systems, and these systems are operating in liquid nitrogen as an operating temperature. The good thing is that high efficient cooling equipment is available for operating in that liquid nitrogen level. So this is a very advantageous thing for using superconductors. In this table, you can compare some of the main characteristics, especially space and weight, very low against conventional systems. Significant lower CO2 footprint is coming together with the highest efficiency of all electrical materials. Because of the completely enclosed system, we have highest safety and easy transport installation due to the very low weight of that system. Mr. Bednarz, who is the Nobel Prize winner in physics, he supports the superconductivity, and he strongly believes that superconductivity will be the technology for this century. Today, I'm going to present to you 5 cases how aluminum industry can benefit with superconductors. My experience in the aluminum industry shows that superconductivity can be installed for collector bars, for MFC, for magnetic field compensation, and also for transport of current from a close by power source to the pot line and others. And I will show you 5 cases, and you can decide if you can use those cases in your aluminum plants. First, collector bar. The collector bars are transferring the currents from the rectifier units to the pot line. They collect the current from different units. In this case, on the picture, you see 4 units, and plus and minus are collected by superconductors to the pot line. The advantages are here we are not losing any power over the collector bar. That means there is no thermal output, no thermal emission. We are highly efficient. We are very compact, very light. We are, and by this also the OPEX, the costs for operation are reduced. So collector bars could be a very, very good application for superconducting systems. If you are going to extend the collector bars by standby rectifiers, sometimes this happens only after a certain time of year when the existing rectifier units need to be maintained or exchanged. Then sometimes rectifiers are installed that can be connected to different pot lines. And these interconnecting bus bars are very often in situations which are not that easy to install. So we are coming close to strong magnetic fields, and we are coming close to existing structures. So superconductors, which are completely encapsulated, can be installed in every narrow and tight environment. They allow tight bending radius, and of course, because they have no losses, they reduce also the CO2 footprint. In the third case, I want to bring to your attention the magnetic field compensation. On magnetic field compensation of today, large dimensioned aluminum bus bars are positioned around the pot lines or around a series of pots. The problem very often is that space is not available as required, and here superconductors help a lot. Superconductors have a very compact design, a very slim design with small outer dimensions. They are enclosed in a stainless steel pipe for high temperature protection. Even on a run out of aluminum, this will not destroy the system, but will just run over it. And we are saving more than 80% of the total power of an MFC because there are no resistances, electrical resistances in the superconductor loop. The high protection degree of IP68 gives also a lot of safety to operators. So for magnetic field compensation, this would be an ideal solution which can be adapted very well to all site conditions in an aluminum plant. If you want to connect to a nearby power source, let's say a wind park, solar plant, or a hydro plant, for upgrading your total power, there is a possibility to place directly the rectifier at the power source and to cross the distance by superconducting busbar system. This would avoid a two-step or three-step power conversion up to with two transformers up to 110 kV in case you have a 400 MVA system. So lower investment costs depending on the length are omitted. You don't need to transfer the power to different levels. You definitely save off OPEX, and on the safety point of view, low voltage transfer is always safer than high voltage transfer. A fifth case is on passive superconducting magnetic field shielding. There, in this case, one of the features of superconductors are used, and that is superconductors are perfect diamagnets. Diamagnets do not allow that magnetic fields from outside are penetrating them. And by using that as a shield, arc welding is possible on the other side of a diamagnetic of a superconductor in strong outside magnetic fields, because the superconductor is protecting the arc against those outside magnetic fields. And this is one example how to make the work in magnetic fields easier for welders and to allow a good weld instead of a weld which has not a high quality. How does superconductor busbar systems look like? First of all, we have to make a connection to the existing busbars or to the existing rectifiers, including switches and everything that is around. So we have all the experience from our past to design aluminum busbars and use them as an interface to the so-called current leads. The current leads are important, and they are transferring warm current, ambient current, into the cold current of the liquid nitrogen. So these are the interface between ambient and the liquid nitrogen environment superconductors need. The whole busbar system itself is subdivided into elements. The elements consist of an outside cryostat, which enclose the inside positioned superconductors. To keep everything on the same temperature level inside, a cooling system is necessary, and definitely a smart monitoring and control system will take care that this is operating under all different operation conditions of the plant. On the left side picture, you see a current lead. You see the name IceLink on that vessel. And here you see the transformation from ambient temperature to liquid nitrogen temperature. From the bottom, the busbar system is going away and then up. So we have vertical and horizontal parts connected with an angle. And you see that this angle is right sharp. It's a 90-degree angle, but we can also produce every direction of the angle. On the right side, you see our busbar system installed above a switchgear. Under a ceiling above there is a electrolyzer. So the space between the busbar and the crossing pipes and the ceiling was very narrow. We had a total clearance of about 250 millimeters, and the busbar system itself is about little bit more than 200 millimeters in width. So there was just very limited space to install that. This is not possible for any other busbar system or for any other cable system. So this is one of the unique features. You see it here, very compact and conducting here 20 kiloamp. Is the technology ready to use? Yes, it is. We demonstrated that and we showed that in an industry installation at BASF in Ludwigshafen here in Germany, where is the largest integrated chemical plant worldwide. We have done a 20 kiloamp DC installation in a live plant during production, during operation, and we did all industry qualifications that are necessary for running a system in a live plant. So that was not a greenfield installation, but a installation in an existing plant. In this year, we will do an installation at TMS aluminum plant in Förde, which is also in Germany. And we are going to install a busbar system as a demonstrator for 200 kiloamp. So it's just factor 10 above the 20 kiloamp. And this is called Demo 200. And below there, you see the website. You can visit the website of Demo 200. It will be installed in a cryostat with an outside diameter, let's say, of 350 and maximum 400 millimeters, 200 kiloamp enclosed in 400 millimeters maximum is a tremendous advantage. So coming to my end is, I want to summarize, we are superconductors support green industry. It's compact, can conduct very high currents with zero loss. We are ultra safe and very highly protected, and we can bridge a lot of distances with the highest efficiency. Also, the connection to other applications like hydrogen brings a lot of advantages. And if you want to know more about that, there is a paper issued in this event, and you can always contact me for more questions. Thank you for your attention and have a good time. Bye-bye.